All right, today's lesson is add rational numbers. And for the warm-up, we want to watch this video, and it is just a review of adding fractions with different denominators, okay? So I'm going to play the video. I'm going to record it, and then we'll start our lesson.
Denominators. We keep them up when they're unlike these problems. We're real good, too. But you can't be any gig off the street. You gotta be handy with your brain, if you know what I mean. Earn your keep. Change was a clear, bright day. Sitting in class, all the kids are trying to run, trying to do some math. The problems on the board, we gotta get them done. Putting in that work so we can have some fun. East side, the left side, hey, it's time to add. Back today, when I noticed that the bottom was not the same. Ain't no problem, cause you know just what to say. These denominators are not in common, gotta get them the same. To solve this problem, grab my brain, grab my lucky pen. Gonna change your mind using LCM. Next thing I got 3 quarters and I'm at S1A. Gotta check and see if the bottom is the same. Now I gotta stop and talk to LCM. That's the least common multiple is number 10. So I list the multiples of 4 and 8. I find that the LCM is 8. It's gonna be the one that works the best. I looked at my teacher, said, man, what's next? One of these over has an 8. Gotta keep the other one so it looks the same. Make it on the bottom. Now I turned 3/4 into 6/8. I can't believe it was such an easy way. 8 on both sides to start up top. After numerators just straight across. I got 6 plus 1, you know that's 70. You're almost done. 6 plus 7, 7. 8 on the bottom, so you look the same. 7, 8, 7, 8, you cannot be changed.
Here's our intro. Remember, you want to fill in your notes with the bolded words. The rules that apply to adding fractions and decimals apply to all rational numbers. Adding fractions. So you know when you're adding fractions, you need to have, what did it say in the video? Common denominators. Very good. The rules for adding positive and negative numbers also apply for rational numbers. So if you're adding integers with the same sign, what do you do to the numbers? So you get the same. So if you add integers with the same sign, you just add the numbers and keep the same sign. If you're subtracting, if you're adding integers with different signs, what do? When you add integers with different signs, you subtract the digits and take the sign of the bigger number. Is everybody with me? And of course, if you are subtracting, you do that keep, change, right? And then you follow your rules for addition. All right, so we're doing example 1 and 2, and here we are adding mixed numbers, okay? So when we are adding mixed numbers, what I would suggest when you're adding mixed numbers with different signs, my suggestion to you, and this is how I did it when I was in 6th and 7th grade, is I changed those mixed numbers to improper fractions. Do you guys remember how to do that? Okay, let's review. So in this direction, when you change them to mix the improper fractions, if you have the negative, you're just going to not count that. You're not going to worry about that at first. So you're just going to bring the negative down. All right, in this direction, we're going to multiply. And then when we go in this direction, we're going to add. Is everybody clear? So 6 times 3 is 18, plus 1 is 19. So we have 19 over, the denominator stays the same. Is everybody with me? So the denominator is 6, that stays the same. So we're going to put this over 6. So we have negative 19 over 6. Now we're going to add, we're going to do the same on the other side. So 6 times 2 is 12, plus 5 is 17. So we're going to add 17, and again, the denominator stays the same. So that's 6. So now we have mixed numbers, different signs. What's the rule? So here, we've got, all we're going to do is we're going to look at this, because the denominator stays the same. You with me? So we're going to subtract the digits and take the sign of the bigger number. So 19 minus 17 is, okay, so 2. So this is equal to 2, and we're going to, the denominator stays the same, over 6, and we want to take the sign of the bigger number. So what's bigger, 19 or 17? So my answer is going to be what sign? Negative. So this is negative 2, 6. Is everybody clear? Now, before we finish, what can I do with this? Yes. And what can I divide by on both? Yeah. So we're going to divide by 2 here, divide by 2 there. Right. So this is going to give us a negative, don't forget your sign, negative 1/3. All right, take 2 minutes and then do this next problem with your table partners. Okay? Don't forget to change those mixed numbers to improper fractions. And then follow the rules for integers. All right, so for example 2, we do the same thing. We ended up with 43 tenths plus a negative 19 tenths. Then we subtract the digits and take the sign of the bigger number. So that gives us the 24 tenths. That gives us the 24 tenths. And then we change that improper fraction back to a mixed number and then simplify. So you guys go ahead and just cross out example 4 because that's the same as the other example. So we're going to do example 3. Now, here we have a negative 3 1/3. Again, in one direction we multiply, the other direction, in this, right. So in this direction we multiply, and in this direction we add, okay? So, and then we just put the negative down there, right? So this is going to be, oops, this is going to be a negative, now what's 3 times 3 is? No, 9, plus 1 is 10. So this is going to give us 10 thirds, okay? Plus 5 times 4 is 20, plus 1, 21 over 4. Now, can I add those the way they are? No, we can't, because what do I need? We need the same denominators. We need common denominators in order for us to add fractions. So, with 3 and 4, what is the common denominator? What number can 3 and 4 both be divided into? 12. Good job. So, how do I make 3 into 12? Multiply by 4, right? So, and this is how we're going to show our work. You guys make sure you're writing this down. Multiply by 4 down here, and we multiply by 4 up there. Now, how do I make the 4 in the next fraction into a 12? Multiply by 3. So over here, we're going to multiply by 3, and then multiply by 3. Is everybody with me? All right. So now, we've got a negative, 10 times 4 is 40, so that's negative 40, over 3 times 4 is 12, plus 21 times 3 is 63, over 4 times 3 again is 12. So now we have negative 40 twelfths plus 63 twelfths. different signs, what do I do? Subtract the digits and take the sign of the larger number. So, and again, you guys, when we're adding fractions now with common denominators, you're only looking at the top, right? So, what is 63 minus 40? So, this is going to be equal to 23 over, and the denominator stays the same, right? So that's going to be a 12 down there. Now, is it going to be a positive or a negative? Very good. It's going to be a positive because 63 is the bigger number. Now, this is an improper fraction. We want to change it back to that's not how we call it, mixed number. Very good. We're going to change it to a mixed number. So how many times does 12 go into 23? Once. Because 12 times 2 is 24, right? Right? 12 times 2 is 24, so it only goes in once. So this is going to be 1 with how many left over? So here, this is going to be 11 12. And there's your final answer. All right, so now we've got a word challenge. Okay, it says, Sherry walked to a new friend's house. She first walked 7,500 kilometers. Then she realized she had gone too far, so she walked 2/5 kilometers back the way she came before arriving to her friend's house. How many kilometers away is Cherie's friend's house from where she started? Okay. So first she walked 7,500 kilometers, right? Then she said, oopsies, I went the wrong way. I went too far. Then what'd she do? Yeah, then she walked back. So now she's going this way. How far did she go? 2/5 kilometers, right? And this is where her friend lives. Now the question, let me highlight the other part. So she walked back this much. Okay? Now the question is, how far is it from where she started? So we want to know that distance. So what operation am I going to do here? Very good. Yes, we are going to do subtraction. Very good. So can anybody tell me what the subtraction problem is going to say? Very good. So here is our problem. We've got 0.75 minus 2/5. Hello, those are two different kind of numbers. What can I do here? Okay, so we can change to decimals or we can change to fractions. Easier because you got a calculator, right? We want to change this. We want to change that to a decimal, right? So in your calculator, how are you going to put it in the calculator? Good. So in your calculator, you are going to type in 2 divided by 5, and what did you get? 0.4. Very good. So here we've got 0.75 minus 0.4. And now, put that in your calculator and tell me what you got. So this is going to be equal to 0.35 what? 0.35 what? Kilometers. Very good. 0.35 kilometers. So she is 0.35 kilometers from where she started. Is everybody clear? All right. So for example 6 and 7, oh, there's 3 different numbers in here. Is that a problem? No, it's not a problem, because all we have to do is make apples and apples. We need to make them either all fractions or all decimals. Is everybody with me? So, for example 6, what would you like to do, decimals or fractions? Oh, wait a second. Nope, can't do it. Because in your calculator, type in 1 divided by 6. and tell me what you get. So because 1/6 is a repeating decimal, we have to use fractions. Is everybody with me? All right. So let's start. So we've got a negative 1/6. Oops. Negative 1/6 plus, now we want to change that next number to a fraction. Can somebody read that number for me correctly? So this is 2/10, okay? I'm not going to simplify it right now because if I need the tenths for common denominators, I'm going to leave it, okay? So that says 2/10. So plus 2/10. And now this second one, this third fraction, I want to change to an improper fraction, right? Remember, you multiply in one direction, add in the other. So 9 times 2 is 18, plus 5 is 23. Okay, so this is going to be 23 ninths. So now, you guys, for adding fractions, what do I need? Common denominators. Yes, we need common denominators. So what is a common denominator with 6, 10, and 9? Good. So the common denominator here, you guys, is 90, okay? So we've got 90 here, plus we need this to be a 90, plus we need this to be a 90. Oops, not 19. Sorry, 90. Okay. All right, so we need to multiply this times 15. We need to multiply this times 15. What do I need to multiply 10 times to get to 90? 9. So times 9 here, times 9 here. And what do I need to multiply 9 times to get to 90? Times 10 here, times 10 here. Is everybody with me? All right. So now, you guys, we can finish our fractions. So this, by the way, don't forget to put a negative here. So that's 1 times 15, of course, is 15. And then 2 times 9 is 18. And then 23 times 10 is 230. Okay. So now we can combine our fractions, right? So can I put all the positives together and then do the negative? Can I add in any order I want? You can, because addition has the associative property. Okay, so what we're going to do is we're going to put all of our positives together. So this positives and this positives. Okay, so what is 18 plus 230? So we've got 248. So this is 248 over 90. And then just bring down that other part. So that's going to be negative 15/90. Is everybody with me? So now we have fractions with different signs. What do I do? What is the rule when I'm adding numbers with different signs? We take the sign of the bigger number, so the answer is going to be positive, right? And what do I do to the digits? You subtract them, right? So use your calculators if you need to. 248 minus 15 is what? 233, right? So this is going to be 233 over 90. And is that going to be we said the sign is going to be what? Right, we said the sign is going to be positive. So now we have an improper fraction, and now we need to change that to a mixed number. So use your calculator and type in 233 divided by 90. So it goes in 2 times, right? What's 2 times 90? 180. All right. So we've got 90 goes into 233 2 times. Now, we want to know what's left over, so you're going to subtract 233 minus 180, which is 53. Okay. So 53 over 90, and there's our final answer. Now, I would like for you to do the next one with your table partners. Remember, and you're going to take two minutes, and then I'll check on you. Remember, I would like for you to check to see if you can change the fractions to decimals, okay? And if you don't get a repeating decimal, if you get a terminating decimal, then you can go ahead and change everything to decimals. If you get a repeating decimal, then you have to use fractions. Is everybody clear? All right.